Okay, so welcome back. And today what I wanted to do is talk about some riddles that my grandfather gave me when I was growing up. So I might have been maybe 7 years old or so, and my grandfather would give me different riddles, and you could solve them using common sense. But now that we're talking about logs, you could actually use logs to solve them. So let's go over it. The first problem on the worksheet says that a bacterium is placed in an empty bottle. I'm a terrible artist, so you could laugh if you want. That's awful. But so we have one bacterium that's placed in an empty bottle. The size of the bottle doesn't matter. And the bacteria population doubles every minute. So we have exponential growth. Really, whenever anything doubles every minute, or you have doubling, that uses 2 to the x. This is modeling. This is a modeling equation if you have something doubling. If you have something tripling, we use 3 to the x, and so on. Right now, that the coronavirus, at this point in time, after the first phase, it has slowed down. But the reason why it was so dangerous is because the number of deaths were, doubling every 3 or 4 days, which is terrifying. But anyway, the model for something doubling is 2 to the x power. If the bottle is full after 1 hour, how long will it take to be half full? So we have one bacterium in a bottle. The population doubles every minute. And if the bottle's full after an hour, how long until it's half full? So let's make a chart to help us get organized. On the chart, I'm going to have a row for time and a row for the bacteria population. Now at time 0, and remember time is in minutes, we have one bacterium. After 1 minute, 1 doubles to 2. After 2 minutes, it doubles to 2 doubled is 4. 3 minutes, we have 8 bacterium. 4 minutes, we have 16. And this keeps happening until we have 60 minutes and we have a full bottle. So an equation that we could use to model this is we could say that the population is equal to 2 to the number of minutes. And you could check, right? So let's take this first one. If we plug in 1 for population and 0 for minutes, 2 to the 0 power is 1. We could plug in like this over here. Plug in 3 for minutes and 2 to the third is 8. So you could see that our model does make sense. But the question's asking us, it's full at 2 to the 60th after an hour. When is it half full? Well, the half full population would be half of 2 to the 60th, right? Or another way to say this is when the population is half full, that is 1/2 of 2 to the 60th. And we want to know after how many minutes does that happen. So we could say, when is the population 2 to the m power, after how many minutes do you get 1/2 of 2 to the 60th? After how many minutes is the bottle half full? This is an exponential equation, so let's figure out what 1/2 2 to the 60th is. That might be a really big number for our calculator. And it is, so let's just use logs then, because we can't type this in right now. So I'm going to take the log of both sides because it's an exponential equation. We could bring the power down here. Remember, we're looking to solve for minutes. This is actually a product property. It's log of 1/2 plus the log of 2 to the 60th. We actually have a few other properties we could use here. This is a quotient property. We have a power property. So what I'm going to do is I'm going to take both sides and divide by the log of 2 to get m by itself. We didn't really have to do all this. We could have just typed in log of 0.5 times 2 to the 60th. I just wanted to give you a refresher on the properties. So I'm going to type in the log of 0.5 times 2 to the 60th, and I'm going to, that comes out as 17.7608. Going to divide both sides by the log of 2. And we get that m is equal to 59. Remember, it's 59 minutes. So let's just make sure that this makes sense. So after 59 minutes, this is saying that the bottle is half full. Well, 1 minute later, if it's half full, 1 minute later it would double, so it would be full. That would make sense. So it's a pretty cool problem. Usually most people guess after 30 minutes. If it's full after an hour, half of an hour is 30. That would happen if the growth would be linear, but this growth is exponential, so it does make sense. If it's half full at 59 minutes and then it doubles, it would be full after 60 minutes. Okay, and there's one more problem I wanted to talk about today. It's talking about having two options. So one option is having $1 million in cash, or having a penny that gets doubled every day for 31 days, which is how many days are in March. Well, if we have something doubling, we know that we're going to have to use like a 2 to the x formula. So let's see if we could figure this out. I'm going to have the amount of money on top, and I'm going to have the number of days on the bottom. So on the very first day, after 0 days, we have a penny. Well, 1 day goes by and it doubles. 2 days go by and it doubles. And this happens for 31 days. Now the question is, would you rather have $1 million or would you rather be patient and wait the 31 days? Well, this is similar to the problem we just did, where the amount of money is equal to something doubling would be 2 to the x power, or 2 to the number of days power. But the difference between 1, 2, 4, 8, and 0.01, 0.02, 0.04, 0.08 is we are dealing with a penny here. So this would be the equation that would model this. All right, so let's figure out how much money would you have after 31 days. That would really determine which option you take, right? So the amount of money you would have after 31 days would be 0.01 times 2 to the 31st power. So 0.01 times 2 to the 31st power is 214,74836.48. So $21 million compared with $1 million. I would choose this option. That's the option that I would pick. Now, for homework, what I'm going to ask you to do is I'm going to ask you to do two problems. Problem number 1 is how long would it take with option 2 to reach $1 million, or another way to say this is, when is the break even. Break even means, well, if you pick the first option, if a friend of yours picked the first option, they got $1 million. How long would it take you to also hit $1 million? All right. And then the second question I would like you to answer is, let's see here. I would like you to answer, would it make a difference if we used February, which has 28 days when it's not a leap year, instead? All right, so for homework, I would like you to figure out those two answers, and we'll talk soon. Thank you very much. Have a nice day.